Is it on? Okay. Okay, let's start our presentation. Then I will ask Stephanie as our first presenters. Thank you for doing us a favor, okay? Okay.
Yes. Okay. Good morning, everyone. And I will present about my discussion with my teammates. And this is the first one. A prior, what is the expected relationship between CM and its of the other variables? As we already agreed together from the last class, we can see that the relationship between female literacy rate and child mortality rate have a negative relationship. And for the relationship between the PGNP and child mortality also have a negative relationship. And then for the total fertility rate and the child mortality have positive relationship. And for the question B, regress child mortality on one independent variable and obtain the regression results. And for my group, we got the option E, which is the one independent variable is TFR, the total fertility rate. And this is what we got from the eViews. Yeah, we have here have the results like this one. And then for the next one, we need to regress CM on two independent variables, which is female literacy and total fertility rate. And this is what we got from the eViews, as we can see. And then for the last one, regress child mortality rate on three independent variables, which is all of the variables, that is FLR, PGNP, and also the FR. And this is what we have. Okay. And for the second question, if the regression in D is the correct model but you estimate B or C, what type of specification error is committed to document the consequences of this type of error? Show all the calculations. So the first one, we suppose that the correct model is D with the three variables, but we estimate B with only one variables. So this is the results. It's the same with the results above with CM and three variables, and this one CM with only with TFR. And this is FLR as the dependent variable with TFR, and this is PGNP with TFR. And this is how we calculated from the correct model, the estimated model. And this is auxiliary regression, FLR and PGNP as the dependent variables. And this is the bias for the TFR, and we got the same results between gamma 3 minus beta 3 and alpha 3 times beta 1 plus omega 3 times beta 2. We have the same answer here. And then the second one, suppose the correct model is D, this one, and but we estimate C, which is CM with as the independent variable, and independent variable is FLR and TFR. So this is the correct model, the same with above, and this is the estimated model. And this is the auxiliary regression with PGNP as the independent variables. And this is, we calculate the bias for FLR and TFR, and as we can see, we also have, we can say it's the same answer, but just a little bit difference. And for the TFR, we also have the same results. And the third question, suppose you estimate B or C, how would you decide if it is worth adding the other one or two variables to the model? What tools would you use? Show the necessary work. So the first one, we are comparing the adjusted R square. From only one independent variable model, we have the adjusted R square 0.442, and then for the two variable model we have 0.702, and for the three variable model we have 734. And between those models, it shows that the adjusted R square from the three variables model is the highest among the others. So indicating that those variables are relevant variable and worth adding into the equations. And the second test is about the t-statistic. Yeah, we calculated this before from the critical value, p-value, and the confidence interval approach. It is concluded that all of the variables, which is the FLR, PGNP, and TFR, are statistically significant to CM. All of these tests support that the variables is important. And then the next test is about the bias. As we can see from the one variable model, the TFR is significantly changes from 33 to 13. And also that we can see that also like changes also in the FLR to from the second two variable model to three variable models. It also shows that some changes that indicating a bias in the original results. And this is for the AIC, BIC, and Hannon-Quinn criterion. From the AIC, BIC, or also Hannon-Quinn, it shows that from the only one variable model up to three variable model, it shows that the value keeps decreasing once we add the independent variables. So from here to here, yeah, we can see that the number is decreasing. The same with BIC, and then from the Hannon-Quinn. So based on all of the tests above, it's just that all of the variables, female literacy rate, PGNP, and also total fertility rate is statistically significant to the child mortality rate and worth adding and should not be omitted from the equation. Thank you.
Isn't this excellent? Very good, right? Okay, thank you very much. You know, you can see all the logic is very, very clear. Okay, thank you very much. Thank you. Who will be the next one? Okay, Evan.
I can't promise it will be as excellent as the previous one, but I'll try my best.
Oh, sure. I believe everybody, you know, really try your best.
I tried my best until 1 a.m. 30, so maybe it wasn't my best.
Well, okay.
No. So here listed the different variables we have. Okay, well you spend a lot of time on it too, so you probably know them already. So we have the child mortality, the female literacy rate, the per capita GNP, and the total fertility rate in the relevant years here. So the correct equation would be this one. So here we have the expected relationship with the dependent variable. So the more educated the female, the less child mortality, the more income, the less child mortality, and the more woman is giving birth, the highest chance of child mortality. Here you can see our equation with the expected sign for each variable. So then we launch our different regressions. So here only the fertility rate. Here we have the statistics, the main statistics for this equation for this regression. Then we go with also the fertility rate plus the per income capita. Here. Then you have the statistics here. And finally, we add the last variable, which is the number of child. No, yeah, okay. So we have our last regression with here the main statistics. So that's our three options, B, C, and D. Now we go on. So what about the estimated bias? What of specification error is committed? I might be wrong here, but I said it was an omitted variable bias, which means that by leaving these two variables here out of the model, as they are significant variables from the theory, we can expect their absence in our regression, especially so in B and C, as you see, to force the expected value of the other variable expected coefficient here to differ more from what its true value is. So let's go for model B. We omitted two variables. So we run the omitted variable test. So we have all the data here. Okay. And we get, so that would be our equation if you would run the actual regression without these two variables. So now we were going to try to calculate the expected bias. So to do so, we have to take the coefficient of these two variables in relation with the variable we didn't omit it. So the variable we did not omit it is fertility rate. So we used the first omitted variable as dependent, this one as independent. We get here the stats, so with the coefficient that we are looking for to calculate our expected bias. Same for the second omitted variable. Here, sorry, maybe I should go, okay, here. And finally here. Okay, so we have our two coefficients of the of the equation relating both the omitted coefficients and the non-omitted coefficient. So that is our formula for the expected bias. So what we do is that we have the coefficient when we don't, so we run the regression analysis with all variables, right? So here are the two coefficients if we don't omit the variable, okay? And here are the two coefficients of the specific regression analysis we run in order to find the relationship, the impact of this omitted variable on our FLR variable here. So here are the actual coefficient that I'm not gonna scroll up again because it's all in the previous regressions, and we got this final expected bias, which is negative. What I say this is negative because that's actually what's gonna interest us the most for the next part. So okay, so that was for the first model, model B. Well, so let's go for the last model where we only omitted variable TFR. Okay, so here are the data. That would be that is therefore the actual equation for this model here. Okay, so now we go again. We calculate the coefficients with the dependent variable as the variable we did not omit it, and the one we omitted. So here is the final equation we got, and the expected bias here. And finally, we compute our I just have to check to be sure. Yeah, okay. So our omitted variable coefficient in relationship to other non-omitted variables, and the normal supposed coefficient, expected coefficient, if we don't omit it. And we get this final expected bias, which is also negative. All right. So now the most interesting part, how do you decide if these omitted variables should be added to the model? So there are a first way, which is the expected bias analysis. If the sign of the expected bias is the same as of the unexpected result, then the omitted variable might be the source of this unexpected result. And this is if the expected bias in the same sign is not the same as the expected result, then the omitted variable is very unlikely to be the source of this unexpected result. So for B, for the model B, the omitted variables are PGNP and TFR, and the sign of the expected bias is negative. All right. So here we have FLR, which is also negative. So the sign of expected bias matches the sign of an expected result. Therefore, the omitted variable might be the source of the expected result. So here, quite honestly, I didn't find that this number was really crazy, but I just wanted to try the expected bias analysis so that I could expose it for you. And then we can do that for model C. Which is going to have the exact same result. The sign of the expected bias match the sign of the unexpected results. As you remember, so for our two expected bias, the signs were both negative. And here, again, FLR, GNP, both negative. So for me, it's more about just the negative relationship between these two variables and the dependent variable. But, at least we did the expected bias analysis. So now, we can use the fourth theory criteria. I think I made a mistake here. It's not exactly that, but you'll see eventually everything matches up. So comparing the adjusted R squared of different model, I've been a bit lazy, quite honestly, because it was quite late yesterday night, and it's not my thesis yet. So I just put when we omitted all variables, like the two, and when we put both, right? So in reality, you should do it for every omitted variable and not be lazy like me. Okay. So so here you see the R squared actually spikes out, increases from the two model, and what happens is when the R squared increases, when other variables are added, the variables should be included. That's the first sign that our variables are relevant. Then the t-statistics. Is the variable estimated coefficient significant in the expected equation? So I did a decision rule. I'm not sure it was exactly what I should have done, but I did it yet. So here are our degrees of freedom, the critical value. I took a 5% significant level, and we're going to do one-sided test. Here are the null hypotheses for PNGP, because so the alternative hypothesis is getting a negative coefficient, and because we expect a negative relationship with a dependent variable. Finally, we are good. Variable PGNP is relevant. For TFR, we have the opposite. We expect the coefficient to be to have a positive relationship with the dependent variable, so to be positive. And here we got also variable TFR being relevant. Then next, so do the actual values of the coefficient actually moves significantly when we add other variables. We go from 2.3, minus 2.3, or even 2.4, I could say, to minus 1.76. All right. So that's quite a big move, I would say, relatively to the first value. So let's say that also we conclude other variables should be included because the FLR coefficient changes significantly when they are added. And now we have the three criterions, so IKK, Schwarz, and Anna Quinn, the three criterions that we've been talking about recently. So the smaller the better, and if you keep decreasing, means that the variable added were important. And here you can see again, it's really slightly, very slightly decreased, about 0.2 points for each criterion. But still, it's not a very crazy result, a very, very impressive result, but still it decreases. So let's conclude that, therefore, we can think the variable were important. Okay, so that was all for fourth criterion rule I wanted to give you. Okay, thank you very much.
Okay, good, good. Who will be the next? Nobody? How about Steve? If you don't say, then I'll call my name. I'm sorry.
Hello, hello. Okay. Hi guys. So okay. We're using option D as our for answering the question. So first question is what's the expected relationship between CM and each of the other variables? And CM here stands for child mortality, and FLR is female literacy rate in percentage, and PGMP is per capita GPN, which is gross national product in 1980s, and TFR is a total fertility rate. So for beta 1, FLR is expected to have negative relationship with child mortality, because I'll talk about in question number 3. And PGMP is expected to have a negative relationship with CM, and the TFR is expected to have positive relationship with CM. Okay, so this is the regression model for just PGMP as an independent variable and CM as a dependent variable. And for our group, this one is the for 2 independent variable with PGMP and TFR for dependent variable child mortality. And yeah, this is the 3 independent variable. As you can see, the coefficient here, it's negative for FLR, PGMP for it's negative 2, and it's positive for TFR. So it kind of match up with our expectation. Okay. So if regression in D is the correct model, which is 3 independent variable, but you estimate only 2 or 1 independent variable, what type of specification is committed? And according to a result of B and C and D, the one I use is adjusted R square, which is this, and AIC is gradually decreasing. So this means that the independent variable is as the independent variable increase, the equation become more relevant with dependent variables. So added independent variables should be neglected and implies the omission of relevant variables. And for this question number 3, I will explain the detail about deciding the worth adding variables. So the first part, I use theory, which is the basic concept of the independent variable with the dependent variable. So the question you have to ask yourself is is the variables placed in the equation ambiguous and theoretically sound? And the answer in this one is yes. For FLR is related with CM because FLR is low. It means that the probability they probably don't have good financial sources, which might increase the difficulty of raising a kid. So that's why it's negative. And for PGMP, if PGMP is low, it means that the income of each family is low, which is also increasing the difficulty of raising a kid. And for TFR, it means that the kids can take more financial resources. Since for TFR it's kind of, you can explain it to like for each family, for each woman, how many kids they have. So if the number is low, which means for each woman only have 1 or 2 or maybe 3 kids, then they can take more financial source for each kid, so which will decrease the difficulty of raising a kid.
Excuse me, is this related to financial? Total fertility rate, and also the first one, female literacy rate. Is this all related to the? Can you explain these two variables again?
Okay. So it's not directly related, but in logic you can predict it as. So that's why later I need to prove it. Okay. So for FLR. Is female literacy rate, which means the kind of means the educational level, right?
The most important dimension for these variables, I think, is in education
Yeah,
instead of financial.
but I mean, if you have enough financial source, then you might get educated.
Okay, sure.
Yeah, that's what I think. Okay, so for TFR, it's kind of indirect as well. So for like if the TFR is high for each woman, they have lots of kids. So what do you think for a family if they have a lot of kids? When they have a certain amount of income, right? So in that case, if you have certain amount of kids, but you have more kids, but you have higher income, then for each kid, they will have less financial source.
Well, for these
like that.
variables, I'm thinking that maybe the total fertility rates is about this is the rates for the whole nations. So in other words, if we have more birth, okay, then there's a higher probability to have, mortality rate for the newborn baby.
Oh, okay, yeah.
Okay, this is the dimension we're thinking about it.
Yeah,
Okay, it's not really just for financial aid. Okay, it's for the more birth and more death. The probability to have more death of the newborn baby. I think that's the reason.
Okay.
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 Maybe we really don't know, but more people born, more baby born, the higher probability to have, the dead baby. Okay.
Okay. Thank you. So for t-testing, the second step is t-testing, and then as we can see, the n is 64 in this case, and x will be 1 and 2 and 3 according to how many independent variable we add in for B, C, D result. And the degrees of freedom is opposite, which is this one, 64 minus 1 and minus 1. So it's 62, and same for the other two, 61 and 60. And the T critical value for them, it's almost the same, 1.671. Since the chart didn't have 62 and 61. So we just pick the closest. And the result of it is we expected beta 1 to be less than 0 because we expect it should be negative. So the T for PGMP is smaller than T62, which means there is enough evidence to reject H0.
Since some of them are positive, some of them is negative, so your critical value should post it positive or negative. We have the positive t-test, then the critical value is positive.
Yes.
You have to compare, the comparison purpose. Okay, so you should put positive and also negative
Okay.
to corresponding with your test statistic is positive or negative.
Okay. Yes.
Okay.
Oh, and the result is here. So here. So and for C, T is here. And this is for D. Okay. So it's the same. It's the same for result C. There is enough evidence to reject H0, which we expected beta 1 to be less than 0. And yeah, I didn't do the positive and negative sign in this one. And for result D, for FLR, we expect it to be less than 0, and for PGMP, we expect to be less than 0, and both of these are rejected too. And for TFR, we expect it to be greater than 0, so this is rejected too, according to the critical value. And then by using adjusted R-square, the result for B is 0.05, which is quite low, and then the for C is 0.52, and for result D is 0.73. This incline of adjusted R-square from B to D indicate the result is more significant than result B and C as variables are added in. So do other variables coefficient change significantly when the variables is added to equation? I think there's a significant change from beta 3. There's a significant change for beta 3 from 30.05 to 12.886, which is from this one with only 2 independent variables to this one with 3 independent variables. But I don't know what it might indicate. I just observed the numbers change. Yeah, and this might be a bias. Yeah. So, and for AIC, according to AIC, the lower AIC are, the better the specification. So from result B to D, it goes from 11.36 to 10.23, so which is decreasing. So means it means from result B to D, the model is become more and more relevant with the dependent variable. And for BIC, according to BIC, it's the same rule with AIC. From result B to D, BIC decreased from 11.43 to 11.37. So this also means that there's an error for omitting the relevant variables in this case. And I'm not sure if the textbook mentioned about Hanna-Quinn's equation.
No, we didn't.
Oh, okay.
It's not on our textbook.
Oh.
It's not on the textbook, but it shows on the output. Therefore, I also say that this is similar information from AIC and BIC.
Is there a formula for that?
No,
Oh,
no.
I-
Actually, if we do have the formulas for those BIC and AIC shown in the textbook, but since the computer output is already, show the numbers, you can, check it by yourself.
Mhm.
But you may not have all the information, the formulas needed.
Oh, okay.
Okay.
I want to talk about the difference between
Yeah.
AIC and BIC too, because I think like not much people will think about this. So what I think from textbook, the formula difference is there's a log n.
Yes.
There's a difference. So kind of depends on if you think this variable is important. If you think it is, then you use BIC. If you think it's okay, then you use AIC. But I don't, I don't know. Like, Professor, is this like like what does it mean for?
This is something, you can, maybe it is somewhere in output, but since we're not really talking about how is this formula coming from, actually, we're just working with the information that this formula give us, okay? We didn't really prove the formulas. Therefore, I really didn't go through all the formulas.
Okay.
But are you through with this one?
Huh?
Are you through with your presentation?
Yeah.
Okay, let's go on to question number 2.
Oh. Okay.
Okay, here.
Yes.
This is the answer exactly as this question number 3, right?
Yeah. That when I was writing, I kind of confused about documented concept.
But since we already have 2 presenters shown how to
Oh,
do
yeah.
these questions, then this
mean-
is what we really expected. You have to check with the bias and see, actually you can self-check by yourself that you really understand the concept or not, right? Okay, by doing those bias calculation, you can match the idea whether you really understand the specification error in this question committed. Actually, this is what we call the bias parts. Okay, so you have to show all this bias. How does that bias coming from? What's the difference? Just like you said. No, you didn't say anything
About-
bias here,
Yeah.
right? You have to say that how the formula, models from one variables to second variables, one variable to the third variable, 3 variables, since the correct one is 3 variables, and how these 2 variable models, when it is really 3 variables, then what's the difference, and how those difference coming from, and those kind of relationship tell us that this is really simplification error coming from. So we can sort of self-check whether this model is correct or not.
Sorry, Professor. I saw Stephanie using the auxiliary regression, right? For this question, but I want to ask about the auxiliary regression because according to the formula, it will be will it be on the expected result or it will have the same?
No. The auxiliary regression actually is help us to find out where the bias coming from. Look at your model. Go up to this model. This is a correct model, right? This is correct model. So for example, the FLR is negative 1.76 something, right? But actually if you omitted this or both, okay, then this coefficient would be different. So go up to, this is just using one variable.
So we have to do just to show
So
the difference.
this
in
one,
coefficient?
since this is your estimated model, so the coefficient coming from this model is just this negative 0.011 something. But the correct one, let's go to the correct one. So this one is this part, right? Is this number. And this number, this two coefficient is different. And this is what we call the bias. And how does the bias coming from? Is using the auxiliary regression. The auxiliary regression is the relationship with the one omitted with included. Okay, the relationship with the one omitted means this is the omitted. These two are the omitted, right? So you are using the omitted with the included, which is this one, to be an auxiliary relation. Since it is auxiliary, means extra, means helpful to find out the bias.
So auxiliary regression is used to
Find out the bias from the estimate model and the correct model.
Okay, thank you, Professor.
Okay, so this part is what we really wanted from question number 2. Okay? All right, then thank you very much. Okay. Let's take a break for 10 minutes, okay?